Okay, let's take a look at our last topic here. We're going to be looking at we call this working backwards. In other words, we're going to be going from knowing an area of some value, a percentage or a proportion or a percentile, and really what we want to do is figure out what value is associated with that. So in order for us to do that, we need to go back, find out what the z-score was, and then use our standardization formula to work back to figure out what that value was. Now, in order for us to go from the area, we can work backwards through a standard normal probability table, but we're going to be using the calculator function inverse norm. Okay, let's take a look at a couple of examples here. All right, again, still working with the males. So we know that we have a mean of 69 inches tall. We have a standard deviation of 2.5. Now we are interested in the 90th percentile for height. In other words, we are interested in a height where greater than that particular height is approximately 90% of all of our data. All right, so let's take a look at what we know. We know that 69 inches is the center. We already have done some other calculations that one standard deviation up, we already know that that's going to be our 84th percentile, so that's going to be 71.5. We already know that this is 84%. Okay, based on our empirical rule. And we know that below the next value, 74, we know that the area below here is going to be 97.5%. So we are going to fall somewhere, we're going to fall somewhere hit the pad there. We're going to fall somewhere in between this range. Okay? All right, so our value is going to be somewhere there. So we're looking for the value below which we have 90% of our data. Okay, so what we need to do is we need to figure out how many standard deviations away that particular value is going to be. Right? So now if I draw myself another scale, if I'm at 0, what is the critical value of z that's associated with 90% below? And then I'm going to change that to my value. So what I need to do, I need to figure out what is 90% below in terms of z. That's where I'm going to use my inverse norm function. And that's going to give me the z-score associated with that. Okay, so I'm going to go to second. I'm going to go to my distribution. I'm going to go down to inverse norm. Inverse norm always wants the area that falls below. That's going to be pretty important in just a second here. All right, 1.28, good approximation. So 1.28 is my z-score. Okay, so now what I'm going to do is I am going to use that 1.28. I know that there is some value that is that distance away from my mean in terms of standard deviations. A little bit of algebra is going to give me or 72.2 inches. So the 90th percentile for height, 72.2 inches. Okay. Let's go ahead and do one other example. In this particular example, what we're going to look at is kind of a very similar question, but worded slightly differently. In this case, how tall must a male be to be in the top 5%? So the value is going to be greater than some particular value where it's approximately 5%. Well, again, we know that 69 down the center. We know that above 71.5, we know that is going to be 16%. We know above 2 standard deviations is going to be 2.5%. So it's, again, going to fall somewhere in here. All right, so we want the top 5%. So let's go ahead and mark that out. So we want some value here where above is going to be 5%. Okay. Now again, I'm going to use my inverse norm command. Now remember, the inverse norm wants to know the area that is below. Well, the area that is below with 5% above is 95% below. So that is what I have to put into my inverse norm command. Okay. So I'm going to go ahead and put that into my calculator. I'm going to do second down to inverse norm. I'm going to put in 0.95. Let's call that 1.645. Okay. So this is approximately 1.645 standard deviations above. There's my 1, there's my 0.645. So now I need to convert that back into a value. 1.645 equals some value away from 69 in terms of my standard deviation of 2.5. A little algebra is going to give me 73.11 inches. So approximately, if you are taller than 73.11 inches, you would be considered in the top 5% of all U.S. males.